Dear friends, welcome to Bond with RK Chemistry YouTube channel. In this video, I am going to explain metals, metalloids and non-metals. Element is the simplest form of matter. In periodic table, we have 118 elements. Based on their physical and chemical properties, elements are classified into metals, metalloids and non-metals. Let us compare the physical properties of metals, metalloids and non-metals. All the metals are solids at near room temperature. There are some exceptions. Mercury is a liquid at room temperature. Gallium, rubidium, cesium and francium, these are also liquid at slightly above room temperature. All the metalloids are solids at room temperature. Non-metals, majority of them are gases. Few are solids. Some exception, except bromine, all the non-metals are either gases or solids. Metals are lustrous, shiny in appearance. Most of the metalloids are also lustrous and some are dull in appearance. Non-metals dull colored or sometimes colorless. These are elastic. Metals are elastic. They can be converted into sheets. So these are malleable. And they can be converted into thin whites. So these are also ductile. But metalloids, these are brittle. When you hammer the metalloids, the metalloid will be shattering into different pieces. Non-metals also brittle in nature. Metals, these are good conductors of heat and electricity. The conductivity of metalloids are in between metals and non-metals. So these are semiconductors in nature, and non-metals, these are poor conductors. In periodic table, out of 118 elements, 91 elements are metals, 10 elements are metalloids, and 17 elements are non-metals. So nearly 77% of elements are metals, 9% of elements are metalloids, and 14% of elements are non-metals. So this is a order: metals greater than non-metals greater than metalloids. This is the order of abundance of elements in periodic table. If you take the physical properties of metalloids, these are mostly similar to the metals, but the chemical properties are mostly similar to the non-metals. Let us compare chemical properties. Metals are metallic in nature, and metalloids are non-metallic in nature, and the non-metals are non-metallic. Metals, they have low ionization potential. The ionization potential of metalloids are in between metals and non-metals. The ionization potential of non-metals is very high. When you compare electronegativity, metals are less electronegative elements, are highly electropositive elements. The electronegativity of metalloids is in between metals and non-metals. Generally, the electronegativity of metalloids is very close to 2. In case of non-metals, high electronegative, non-metals are highly electronegative elements. Metals form basic oxides. Metalloids form amphoteric. It means they can react with acids and also base. Some oxides of metalloids are weakly acidic. And non-metals, they form acidic oxides. And metals forms alloys, and metalloids can also form alloys, but non-metals don't form alloys. These are some differences between the metals, metalloids and non-metals. Metallic properties. The physical and chemical properties which are associated with the metals are called as metallic properties. What are the physical properties which are associated with the metal? Lustrous, they are bright, shiny, and also they reflect light. These are good conductors of heat and electricity. These are good conductors. And these are malleable. These can be converted into sheets. When you hammer, metals can be converted into different shapes and also can be converted into sheets. So these are malleable and also ductile. These metals can be converted into thin wires. And some other physical properties, they have close packing structure. Mostly they have cubic close packing or hexagonal close packing or body centered cubic. Metals are hard and dense. Since the structure is close packing, metals are hard and dense. Some exceptions are there. Alkali metals such as lithium, sodium, potassium, rubidium, cesium. These metals are less in dense and also soft in nature. And these have high melting point and boiling point. Exceptions, mercury and alkali metals, these metals have less melting point and also boiling point. Let's take chemical properties. These are electropositive, less electronegative means these are electropositive. They readily lose electrons and form cations. Suppose let us take a metal, this one readily loses n number of electrons and become Mn plus. Suppose if you take sodium, it readily loses one electron and become Na plus and becomes Na plus. Suppose if you take Mg, it can lose two electrons. So Mg2 plus and two electrons. Based on valency, they can lose different number of electrons. Metals form basic oxides. Suppose if you take at least one basic oxide. Suppose if you take sodium, when you react with oxygen, there is a formation of oxide, metal oxide, that is Na2O. So when you dissolve in water, upon hydrolysis, this one will become sodium hydroxide. So the metal oxide is basic in nature. And different metals react differently with water. Suppose if you take alkali metals such as sodium or potassium, they react rigorously. Rigorously they react. Suppose if you take calcium, readily, this one is readily reacts with water. And if you take magnesium, this one reacts slowly. And if you take silver, gold or platinum, these elements cannot react with water. Okay, based on their nature, different metals can react with water with different rates. And most metals displace hydrogen from acids. Suppose if you take metal, when you react with hydrogen chloride like acid, and there is a formation of salt, MClN, and there is a release of gas. This is the salt. Suppose if you take sodium, when you treat with HCl, there is a formation of sodium chloride salt and there is a release of hydrogen gas. Metals replace other metals. Suppose if you take zinc, when you treat with Cu2 plus, the zinc replaces Cu2 plus ions. So this one Zn2 plus and Cu means the copper replaces zinc. Most metals corrode. There is a corrosion of metals in atmospheric condition. At atmospheric condition, there is a corrosion of metals. Suppose if you take iron, there is a rusting of iron due to formation of hydrated oxide. Here there is a formation of Fe2O3 from X amounts of water. Due to formation of this compound, there is a rusting of iron. Similarly, most of the metals corrode in atmospheric condition. And metals forms alloys. Suppose if you take copper, it can form brass. bronze, nearly all the metals can form alloys. In coming video, I will explain theories of bonding in metals. First one is valency bond theory, free electron theory, and band theory.